Hi, everybody. How you doing tonight?
Good.
Good, good, good. Okay, so this is our last official class. So there wasn't big smiles there, so that's kind of good. So for the last official class, so um, next week you will be working on your final projects, finishing those up, and you have to have those turned in before the 10th, like midnight at the 10th. And then I'll get them graded over the weekend and grade final grades then.
Sorry guys, love you, but class is on.
With your final projects, there are 3 options. Those are listed in the class. If you have any questions, you can email me, shoot me an email. If you have ideas that are a little outside of the boundaries, I am fine with that, as long as it kind of fits the parameters of the class. Being creative, you don't lose points for that. Overall, the article critique, the other ones, those are that's probably one of the easier ones from it. The other ones, though, you're welcome to do. You can do abbreviated lesson plans or whatever to fit it into this page constraints, or if you go a little over, I'm not going to dock you too many points. I really won't dock you if you go over. I just don't want something that's like 35 pages long to have to read and go through and get graded and get everybody's in. 1 or 2 of you would have been fine like that, but if I had 30 of them, then that makes it a little bit difficult. So that's why the page constraints are on there. I want to kind of let you know how much I'm expecting with it. So if you have questions, just shoot me an email. It'll be fine. We have 1 chapter to be presented tonight, and that'll be the final chapter. And hopefully you'll see that it kind of ties a lot of things together. With the presentation tonight, have you talked about who's loading it and who's going to click through, or are you swapping it back and forth?
I think I'm going to be doing the whole thing, loading it. So hopefully I don't screw it up.
You won't. You won't. All right. So are there any questions about the final project, about anything in class? Okay. So Kelly, if you want to go ahead and load that up, on the bottom it says share screen. You just click on that and find your document or your web browser. Click on that, and we'll go ahead and get started.
Okay, can you hear me and see the screen?
Yep, looks good.
Okay, great. So we're talking about generating and testing hypotheses today. This is chapter 9. So what if? How many of you play the what if game with your students? I'm sure we use this all the time because we're all teachers, right? So why is this important? We ask these types of questions because we all want to know the answer. We all love a good mystery. We all want to know who did it and why, right? But as teachers, there's a few other things that we're looking for from our students. So we want them to draw upon knowledge that they have, to generate and test hypotheses, to make and test predictions, and then consider various options, and then draw conclusions from that information. So during this whole process here, we want our students to expand their understanding of the knowledge that they just learned, increase their ability to apply it, and then connect all of it to the real life purpose behind this skill. So this is not just for science class. When I hear the word hypothesis, I think of science, and I did not do very well doing experiments. So why is this category important? Generating and testing hypotheses applies to knowledge in 2 different ways. The first one is deduction. So you use general rules to make a prediction about a future event or action. So the book gives 2 different examples for this. Turtles have a shell and they use it for protection. So you would assume that if a turtle sees a predator, they're going to hide inside their shell. The other example was about earthquakes and fault lines. So you want to take all the information that you know about earthquakes and fault lines and use that to predict when the next earthquake would occur. The second knowledge is induction. So this uses inferences that are based on knowledge that students already have or information that's presented to them in the text that they're reading. So the book used the example of characters of a story, and how you would read between the lines and determine how people would act or should act because of different information that was presented to them. I found this really cool image, I thought anyway, that shows you the difference between deduction and inductive reasoning. So for deduction, you start with a theory and then form a hypothesis, then an observation, and then you confirm that your hypothesis was true. And an example of this would be Aristotle. And then for induction, you do this in the opposite direction. So an example of this would be Sherlock Holmes. So you would start with the observation, look for different patterns or clues, form a hypothesis, and then from that you would determine the theory. So I thought that was kind of neat. This is not necessarily what the book said, but I liked it. To compare the two different types of theories, deductive reasoning, there's more pros that the book lists because it gives the students better results and it gives them a more complete learning framework. You need to be very cautious when you use induction because there are so many different opportunities to stray from the topic. If you think about providing students with just a couple bits of information and then you ask them to extrapolate on that or think about what this character would do next, I think you could see where this could go in different directions. And so the students then could walk away with different misconceptions from the activity than what you were intending. So in general here, generating and testing hypothesis is better than a lecture for a variety of reasons, right? So the first, it's obviously more fun, but the other reasons are that it deepens student knowledge because it requires critical thinking skills and form better connections among content, among their own personal lives, and also from the real world. And how do we use this in the classroom? So these are classroom practice for generating and testing hypotheses. So we can use this technique in all classrooms. So if you think, if I do this, what will happen next? So you could use this in history class. What if a certain author or a certain hero or somebody did something different and it changed the course of history? Or you could use this in science class. But there are two different recommended ways to do this. You want to engage your students in a variety of structured tasks for generating and then testing the hypotheses. And then also you want to ask students to explain their hypotheses and their conclusions. So how did they create them and what were their conclusions and did they match? So different ways to engage students. I would suggest probably not doing the scientific method unless you're a teacher that teaches science, because it's kind of, there's many other examples that we're going to go over because we're math teachers in our group, and so we have other fun ways to do it. But basically, you want to go over the same steps that other classmates did throughout the book. So you want to model the process for the students, use familiar content to teach the steps of the processes, provide students with useful and relevant graphic organizers, and then give students guidance as needed. So I think Renee is going to be up next here and go over the 4 different methods.
Yes, I am. Can you guys hear me? Maybe?
Yeah, we can hear you.
Yeah, we can hear you.
Okay, awesome. All right, so the book outlines 4 different processes that we can use to extend and apply the knowledge for our students. So the first one is system analysis. Second is problem solving. Third is experimental inquiry. And fourth is investigation. And the book outlines that we should be intentionally using these in our daily lessons, and that it will help us to increase our students' engagement and help to better deepen their understanding and knowledge of critical thinking skills. So the first process that we're going to look at is system analysis, which is analyzing the parts of a system and how they interact with one another. So the steps that we read about in order to help us analyze a system better is to first explain the purpose of the system, the parts of the system, and the function of each part. So we want to understand what each part does and get down to really understanding each individual piece. And then we're going to look at describing how those parts affect one another. So once we understand each individual part, how do they interact with each other? And then we're going to identify a part of the system and come up with a change to hypothesize what might happen as a result from changing one part of that system. And then, if possible, testing your hypothesis and actually changing that piece is one of the best key parts in order to help students learn. So in the book, they came up with a situation in which a teacher was trying to teach the housing market collapse. And it was a really cool experiment that the kids were able to do. They were in role play mode, and they were all in charge of their own desks, and their desks were a piece of the housing market, and they got to sell and talk about how much each desk was worth depending on where it was in the room. And it gave the students the ability to understand the different parts of a housing market. And then they were able to, through the knowledge of that the housing market collapsed, they were able to come up with predictions and pieces that they could change in order to influence how the housing market could have been prevented from collapsing. So I'm not a history person. That's a really great example. But in math, systems are completely integrated into everything we do. So I was thinking about this as we were coming up with our PowerPoint, and order of operations is a great system that we use every single day in math, and we have to use that in order to get the result that we want. So I thought it would be a great way to use the order of operations to have the students investigate how those pieces individually work together and how changing just one part can influence the outcome of the entire process. And I think that if you've done math with your students and you've done the order of operations, you can see on a daily basis how that process can be easily easy mistakes to make, and then the students get an incorrect answer. Also, as a reading teacher, I thought that the parts of a story would be a really easy way to also talk about system analysis and how like the setting, characters, plot, and conflict all work together, and how changing one piece of that puzzle would change the entire outcome of the story. All right, and then another process that we're going to talk about is problem solving, which involves overcoming obstacles or limitations that are in our way of achieving a goal. So the steps in problem solving are first to identify what we want to accomplish. After we identify what we want to accomplish, we need to figure out, identify, and describe what is standing in our way from us achieving our goal. And once we've identified what's in our way, we can start to figure out how to overcome those barriers and hypothesize a solution that will work to get us to our results. And we need to try our solution, and in different situations we might be able to do that in reality, or we might need to just do a simulation of some kind to see if that solution will work. And then once we've tried that solution, we're going to see whether or not our hypothesis was correct. So the book explains a great example of a band, a group of band students who have lost one of their, or there was an accident, they don't have a drum, and they are in need of a drum in order to perform their music. So the class is in a real life situation, having to analyze and hypothesize different options that might work in order to help them keep the rhythm since that drum is missing. And they come up with 4 great solutions of different things they can use in order to supplement for that missing drum. And they test those 4 options to come up with the best solution. So in math, problem solving is one of the biggest things that we use on a daily basis. And the picture that I put in there, I use a specific problem solving plan in my class that's very similar to this one. And my students start off every single day with a warm-up, a story problem warm-up, in which they have to use the problem solving plan to solve. So I do a lot of guided teaching with this so that they can solve their own problems. And I like a method like this because we have to identify what we're trying to figure out. We need to come up with a plan or a hypothesis that we think is going to help us get our result. We test it out, and then we have to reflect at the end to see if that was the best solution to get to our result that we wanted. And in math specifically, that's something that kids might be able to get an answer, but that doesn't mean that they have, that their answer makes sense. So that end piece of really looking at the solution and seeing if it was the best solution is a really good reflective piece. And now I'm going to pass it over to Katie to do the last 2 processes.
Okay, so the third method is experimental inquiry. So this is the process of generating and testing explanations of what the students are observing. So the first step is to make an observation, and then they're going to be thinking about what they already know about. I'm so sorry, my dog is barking. They're going to be thinking about what they already know about what they're observing, if they've already seen something like it before, or if they've already learned something related to that. And they're going to come up with a prediction. Test out their hypothesis through an experiment, and then spend time evaluating the results. Sorry. Some examples of this are in the textbook. Gosh, I'm so sorry, guys. In the textbook, there's an example. I'm so sorry. I'm trying to get away from these dogs.
It's okay.
Don't worry about it.
There's an example of the students in a science classroom, and they are looking at the changes in rainwater and how that affects erosion. So first they observe something happening. They had an erosion, kind of like a demonstration machine where you could adjust the angle of the slope, and then they would notice how the erosion amounts changed based on the angle of the slope. They would make a hypothesis, and then they would actually experiment it out, adjusting the slope of the angle. And then after that, they would discuss in groups or maybe as a whole class what they found, if their observations were correct or not. And then in my own classroom, I thought an example of this was an activity that I do where we talk about the relationship between side lengths, surface area, and volume. And so we notice the ratio of the side lengths to the area or the surface area of a figure. And then they come up with a hypothesis about what would happen as the surface area grows, what would happen if the side length increases, how that would affect surface area. And then we figure it out by actually creating several examples and then discuss the results as a group. The last process that the book discusses is investigation, which is identifying and resolving issues regarding past events about which there are confusions or contradictions. So the first thing that we do is identify what the situation is, what we already know about it, and then just come up with possible outcomes to figure out if what might happen, and then we determine if any of these are actually plausible or if they're just random possibilities that will probably never happen. So some examples are in the text. There was an 8th grade history class, and they were discussing colonization of North America and how our perceptions about that have changed over time. And so first they talked about what they already have learned about the colonization of North America, and then identify different perspectives about that. They talked about a bill that was being proposed to ban Columbus Day celebrations, and then each group takes a different viewpoint on the topic, and then they have to argue what would happen if their viewpoint, the group that they're representing, if what they wanted to happen happened, how that would play out, and then discuss what they learned about the different perspectives afterwards. And then in my classroom, again with math, the way that one of the ways that we practice ratios and comparing them and looking for patterns is to measure the arm span and height of each student and then determine what the ratio is between those. So a way of introducing that activity using investigation would be to talk about how it's commonly said that arm span and height are equal, and then talk about what ratio that would be if they're equal. And then they can estimate, based on most of them probably know their height, what their arm span would be, and then actually measure their height and arm span to figure out if what they thought would happen happens with their arm span. And one thing that the book emphasized is it's not only important to have students to create hypothesis and then to test that out, but they need to become well practiced in explaining what their hypothesis was and what their conclusion is. So some examples of ways that we can give our students to do that would be to give them samples and templates for their work, where there's a section that requires them to explain what they're coming up with, to give them sentence frames where you explicitly ask step by step, what is the hypothesis? Where did you get that? What happened in your results? What's your conclusion? And connecting those. Have students create videos. Have students create graphic organizers, or the picture on the left is like a science fair or some kind of fair where they have to create a visual and then be able to explain their findings to the community or their parents, and then give them rubrics on how to, that show how you're gonna evaluate them based on what they've done. And I think, is it back to Renee, or is this one me?
I can do this one.
Okay.
Okay, so generating and testing hypotheses with today's learners. A lot of us know that jobs are developing, we have new technologies that are coming out. So helping students to understand how to generate and test their hypothesis is going to be really vitally important for them as our world continues to grow. So we want to give students the skills that they need to be successful in problem solving in the future, and to be able to look at all these problems from multiple perspectives. So I think that quote there kind of helps us to understand that, saying in this way, we give students the ultimate gift of education, the ability to educate oneself and use that knowledge in productive ways. So we want to give those kids the education of understanding how to problem solve so that when they get to problems in the future, they can be our problem solvers. The book also had some tips for teachers. So the first is to provide mini lessons to students to help them understand the process. And we need to make sure we have explicit instructions and a lot of structure in these mini lessons to help students understand the specific process. Number 2, design learning experiences that provide opportunities for students to infer accurate principles. And we really want to make sure that what they are inferring through these experiences are accurate, and that gives us the opportunity as educators to make adjustments when we see misconceptions forming. 3, we need to involve students in designing their own learning or their own tasks. So that might be in allowing students to form their own groups. We might be able to let them decide what role they're going to play in their groups or how they're going to present the information that they are gathering. And 4th, we need to teach the underlying structures of each of the cognitive processes. So those are the 4 that we just outlined. So we need to make sure that students understand how to analyze systems, how to problem solve, how to use experimental inquiry, and investigate. And then let's connect these to the learning theories. And I saw that somebody already made a comment and said, oh my gosh, this totally goes in line with constructivism and how much that's your favorite. So yes, first we got the social learning theory. So students are learning through observing and modeling. Their experiences directly affect the conclusions that they're going to generate. And they have a lot of intrinsic motivation because if they are coming up with their own experiments, they want to find out the results. And then we've got the social cultural theory and constructivism. So our students are going to be learning in a very social context and testing their hypotheses together. They are constructing knowledge from the meaning of their experimental experiences, and they're not going to be able to move beyond their zone of proximal development. So what they know is as far as we can get them at that point. All right, do we have any questions? Okay.
I agree. Very nice job. Good examples, nice connections to the theory, and well put together. You guys as a whole, your classes, you've all done very nice work with putting these together and figuring out how they fit with the theories and how you can actually carry them out within the class. So I'm really impressed. Does anyone have any questions for the group or questions for the good of the order?
I have a quick question.
Okay.
This is getting a little bit ahead, but I'm just looking at that final project and had a question. If we chose to do the unit plan, did you want reflection in there or just the introduction with our templates?
I would think that, I don't know. I don't think there's a place in there, like whenever it's setting it up and telling you the directions, that says that there has to be reflection within it. I'm logging into the class right now to double check. Make sure.
Yeah, I didn't see anything.
Right.
I focused more on it actually, never mind. It's in it does say, not in the instructions, but in the rubric.
Yeah. So you wouldn't have to write a reflection on each of the ones that you're coming up with. That's what I thought. I thought there was a place for it, but I wasn't going to kind of swear to it without double checking. Right. So with your final project, whenever you're pulling it all together, if you choose to do the set of lesson plans, you can use the template for it as you've done with the other ones, or you can use your own, make a shorter framework if there's more lessons that go along with it, or how you want to do that. But as you're working through on it, you can put the reflection at the end instead of with every lesson plan. You don't have to reflect on every one that you haven't even done yet. So if you just want to put the whole thing together and then just add one little piece at the end, that's fine with me.
Great, thanks.
Yeah, not a problem. Anybody else have questions on that?
I have a question real quick.
Sure.
This is my first time calling in on my phone. This is Kelsey Combs. I just wasn't sure how, like, if it showed up that it was me or
No,
not.
it shows up as a phone number.
Okay. So this is Kelsey Combs. That was all.
Okay. Yeah.
Okay, thank you.
Uh-huh. Any other questions on the unit project or the final project or on anything else? Okay. Alrighty then. I will have this posted up. The last one is posted now. I did not have it showing up and I thought I did. So from last week, if anybody had missed, I know some people had asked me to make sure that I had it posted because it wasn't showing. And I will have this one posted as soon as it loads tonight. And other than that, I will not see you next week. You feel free to drop in on office hours tomorrow night or next week. And if there's anything else that I can do for you, shoot me an email and I'll get right back to you. Otherwise, thank you. Have a great night.
Good night, Jen.
Thank you.
Thank you.
Well, thank you guys. It was a great class.
Good night, thanks.
Bye, guys.